In this example, we will solve for the exact solutions for the equation sine of 3x equals negative 5 over 13 in the interval 0 to 2 pi, as well as finding all solutions. In this example, I am going to actually find the full infinite solution set first, and then use that to come up with the answers between 0 and 2 pi. To start, we have sine of 3x equals negative 5 over 13. My goal overall is to get x by itself there. So if I do want to get x by itself, where it is currently being operated by a function of sine as well as a multiplication of 3, the first thing I am going to do to both sides is apply an arcsine function. So if I apply arcsine to both sides of this equation, that will be arcsine of sine of 3x equals arcsine of negative 5 over 13. In this case, since I'm going to apply an inverse trig function, I am going to go ahead and use the infinite solution sets that I know that arcsine is going to work with. What that's therefore going to look like here is 3x is equal to the first infinite solution set being arcsine of negative 5 over 13 plus 2 pi k. And the second infinite solution set is pi minus arcsine of negative 5 over 13 plus 2 pi k. You may notice that we still do not have x completely by itself, and that is still the first initial goal, get x by itself. However, it is very important when going through equations such as this that if you still have more to work on there with x, that you do set up the full infinite solution set first before moving forward. This is very important because what we would do now to get x by itself, which would be to divide both sides of the equation by 3, I am going to divide by 3, but everything is going to be divided by 3, including the plus 2 pi k. So if I divide everything by 3 in both solution sets, that will give me 1/3 arcsine of negative 5 over 13, which I'm not going to simplify any further because I do not know what arcsine of negative 5 over 13 is, plus 2 pi k over 3. Second set will be pi thirds minus 1/3 arcsine of negative 5 over 13 plus 2 pi k over 3. That now gives me the answer for all solutions, the full infinite solution set. This is why it is very important that I set up the infinite solutions of plus 2 pi k first before dividing by 3, otherwise I may have missed this portion of the set of equations. Also keep in mind here that k is an integer. Now, the reason I set up that first before doing the individual solutions between 0 and 2 pi is because I can now use those infinite solution sets to generate the answers within 0 to 2 pi. So let's look at these. Let's start with the first set, 1/3 arcsine of negative 5 over 13. 1/3 arcsine of negative 5 over 13. That is the first solution that we have from that infinite solution set. However, that is not between 0 to 2 pi. You can check that on a calculator if you want, but you shouldn't need to, because arcsine of negative 5 over 13, since that is a negative ratio, I know that's going to be between negative pi halves and 0. It's going to be somewhere in quadrant 4, specifically between negative pi halves and 0. whatever that angle measure is, if you multiply that by 1/3, that still keeps it as a negative angle measure, meaning I know it's not between 0 and 2 pi. But if I add one instance of 2 pi thirds to it, so I'm plugging 1 right now into k, well, now that will take a negative angle measure and add 2 pi thirds to it, which is going to, for sure, push it beyond quadrant 4, somewhere into quadrant 2 most likely. Possibly quadrant 1. However, I already know at this point I now have a positive angle measure, so that's going to work. I should be able to generate another solution using that same solution set by adding another instance of 2 pi thirds. So now adding 4 pi thirds. This I also know is going to fit between 0 to 2 pi because this is 4 pi thirds minus a small angle measure. So I know 4 pi thirds is between 0 to 2 pi. If I decrease it a little bit, that's still between 0 and 2 pi. And if I do that again and add another instance of 2 pi thirds, which will be 6 pi thirds, otherwise known as 2 pi. That I know is between 0 to 2 pi because I had just established that this is a small negative angle measure. And if you add 2 pi to that, that's really like going 2 pi and subtracting a little bit. So that's going to fit between 0 and 2 pi and be an angle measure somewhere in quadrant 4. If I added another 2 pi thirds, though, that's going to go too far. That would have plus 8 pi thirds, which is beyond 2 pi thirds, or 2 pi rather, and I know if I just subtract a little bit, that's not going to keep it between 0 and 2 pi. I should be able to come up with another set of solutions from the second set there, pi thirds minus 1/3. So pi thirds minus 1/3 arc sine of negative 5 over 13. As we've already established, arc sine of negative 5 over 13 is a negative angle measure. So if I am subtracting a negative angle measure, I am realistically going to be adding some amount here. So I have pi thirds plus something. And that something is a really small angle measure, so that should still fit between 0 and 2 pi. Same should also be true if I add 2 pi thirds to this. So pi thirds minus 1/3 arc sine of negative 5/13 plus 2 pi thirds can add to that first term. Pi thirds plus 2 pi thirds is now pi minus 1/3 arc sine. So I've added 2 pi thirds to that first term. This again is going to be pi plus a small angle measure, so that should fit between 0 and 2 pi. As should if I add another 2 pi thirds to this. Pi plus 2 pi thirds is now 5 pi thirds minus 1/3 arc sine of negative 5 over 13. This is now 5 pi thirds plus a very small angle measure. This is still going to fit between 0 and 2 pi. I know that arc sine of 5 over 13 was already between negative pi halves and 0 when I took 1/3 of that, since I knew that it was between negative pi halves and 0. When I took 1/3 of it, that now means it fits between negative pi 6 and 0. Since it's a little bit larger, technically, than negative pi 6, then when I combine that with 5 pi thirds, that's not going to nearly push me past 2 pi. So this should fit as well. You can use a calculator, though, to confirm that, particularly if you're still getting the number sense down. However, this should be my set of solutions that are all between 0 and 2 pi. I would highly recommend in cases like this to find the full infinite solution set first, and then use that to come up with the answers that fit between 0 and 2 pi.